Okay, now gears, as we know, are used for transmission of power and motion from
One
one
shaft
shaft to
to
the
another shaft.
other shaft. Okay, by engagement of teeth. Gears have teeth on their surface. So by successive engagement of teeth, motion and power is transmitted from one shaft to the other shaft. Okay, we already know types of gears. Now here, just through this video, I would like to show you three types of gears, because you already know how the teeth are. Okay, but still through this video, I think idea would be more clear. Now currently, the gears which are seen, which types of gears are they?
Double helical.
These gears are called as helical gears. Their teeth are inclined with the axis of the shaft. Okay, you can see axis of the shaft is something like this. Axis of the shaft is something like this, and teeth are at some angle with the axis. Okay, so helical gears have their teeth cut at certain angle with the axis of the gear. Okay, then here you see two gears. Okay, whenever such two helical gears are used as a pair, then they are called as herringbone gears. What is the name? Herringbone. Herringbone, or the other name is double helical. They are also called as double helical gears. Okay, let us continue with the video. So now, as we go further, currently you can see these gears. Okay, so very simplest gear, that is spur gear. Spur gears have their teeth parallel to the axis of the shaft. You can see the teeth is like this and shaft axis is like this. So teeth are parallel to the axis of the shaft. Okay, and as we go further, now currently the gears which are visible, which are they?
Bevel gears.
They are bevel gears. Bevel gears are cut on the surface of a cone. Cone, you know, cone?
Yes.
Okay, so bevel gears have their teeth cut on the surface of the cone, and they are specifically used for transmission of power between two intersecting perpendicular shafts. Okay, when shafts are perpendicular and intersecting, we use bevel gears. Okay, so you can see this is shaft of one bevel pair or member of the pair, and this is shaft of the second member. Okay, so they are at right angles to each other. Okay, this application seems to be something like rolling operation, or at the same time you can see conveyor type operation is there. Okay, for which all this arrangement is used. So through this video we saw three types of gears: spur gears,
Helical gear and bevel gear.
helical, again in helical, double helical gears, and bevel gears. Okay, worm and worm will use for very large power reduction ratio. Okay, that we'll see later on. Now we'll go to the basics of design of spur gears. Okay, so spur gears are used for transmission of power between two parallel shafts. Whenever shafts are parallel to each other, we have to use spur gears. What about helical gears? Helical gears are also used whenever shafts are parallel to each other. Bevel gears are used when shafts are perpendicular and intersecting. Okay, and worm gears are used perpendicular but non-intersecting, like this, perpendicular but non-intersecting. Okay, so we'll start with basics of. So first, types of gears, as we already know, spur gears, tooth profile is parallel to the axis. Okay, and they transmit motion between parallel shafts. Same is the case with helical gears. These are helical gears. Okay, you can see teeth are at certain angle with the axis. Then here we see internal gears. Okay, these are called as internal gears, but the teeth may be again like spur gears or helical gears. Bevel gears, as just seen, are cut on the surface of the cone and used for perpendicular shafts. Okay, you can see between non-parallel, here it is non-parallel, but mostly bevel gears are used for perpendicular shafts and intersecting shafts, as shown in the picture. Now in bevel gears, These are straight teeth. These teeth are straight with the cone surface. And here the teeth are at certain curve. They are having curve. Okay, so accordingly they are called as spiral bevel gears, and these are called as straight bevel gears. So bevel gears two types: straight bevel gears and spiral bevel gears. Okay, we'll go into much details later on. Right now we'll see only introduction of each types of gears. Worm and worm wheel used for large reduction ratios and whenever shafts are perpendicular and non-intersecting. Perpendicular and non-intersecting. Okay. Rack and pinion, you know, used for rack and pinion.
Angular motion into it.
This rotary motion will be converted into linear motion, or if this is driver, linear motion will be converted into rotary motion, vice versa. Okay, rotary to linear or linear to rotary, rack and pinion. Now, how to select a type of gear for a particular application? Okay, so this is always the first step in design, like which types of gears we should select. In our gearbox application, we selected which two types of gears? Spur and helical gears. Okay, because the shafts are parallel to each other. In our gearbox application, shafts are parallel to each other. That's why we selected spur and helical gears. Okay, so factors to be considered are, all these are very theory and basics. Okay, if you require, I will give you in the form of notes later on. Okay, we'll just discuss now. General layout means whether shafts are parallel, perpendicular, intersecting, non-intersecting. That is the first point. What is the second factor of selection? Speed reduction. How much speed reduction you want, or how much speed increase we want. Okay, based on that, we have to select spur and helical gears from maximum up to 10:1. But in most of the practical cases, they are used for 3 to 4 with a speed ratio of 3 to 4. Okay. Bevel gears are generally used for, what do you understand by this 1:1 and 3:1? What is this? That is reduction ratio. 1:1 means both the gears have same diameter. We discussed in previous unit. When both the gears have same diameter, what will be the speed ratio? Same. That is 1. That means both the gears will rotate at same speed. That is 1:1. And whenever I say 3:1, that means driver gear at 3 speed, driven gear will be at 1 speed. That is reduction of 3. 3:1 का मतलब है reduction of 3. And likewise reduction of 6, reduction of 10. Worm and worm wheel are used for very large reductions. You can see what is the reduction from worm wheel? 60 to 100. That means if worm is rotating very fast, worm wheel will rotate something like this. Are you getting my point? Worm wheel rotating at very large speed. Worm rotating at large speed, because in worm and worm wheel generally worm is driver. Worm and worm wheel में दो components कौन से हैं? Worm is one and other one is worm wheel. Okay. In this figure you can see. In this is worm. This component is called as worm. It is in the form of screw. Worm is in the form of screw, and this is worm wheel. You can see the diameter difference also. They have large diameter difference. Because of this, you can achieve reduction of 60 to 100. This much reduction is possible by using worm and worm wheel. Okay. Then power to be transmitted. How much power we have to transmit? That is the next factor. And of course, how much is the input speed and the cost. Okay. Helical gears are used generally for high speed applications, because that's why in our application we selected first pair of helical gears and second pair of spur gears. I told you the reason also. So this is the reason. Spur gears are the cheapest because easy to manufacture. Spur gears are easy to manufacture than all other types of gears. That's why they are the cheapest. This is comparison of all the different types of gears. You already know shaft layout, teeth. Okay, so accordingly you can easily write difference, and that is very basic point. Actually you must know it, but that may not be asked for examination. Okay. Now we start with our nomenclature of spur gears. So starting with nomenclature of spur gears. This point onwards, I want everyone to be attentive. You please understand all the basic terminology of gears. We start with spur gears. If you understand spur gears well, it would be easy to understand other types of gears. Okay? In nomenclature, we will write few important terms. There are many here in the diagram. You can see. So what figure shows or what this picture shows? These are the gear T. How many teeth are there? Two teeth. Two teeth of a spur gear. Okay. So we can see the distance parallel to the axis. Now where is the axis of this gear? The gear will be something like this. So this is the axis of the gear. Okay. So you can see teeth are parallel to the axis of the gear. That's why they are spur gears. Okay. Now in spur gears we will see what all these terms are. You can see the top of the gear tooth is called as top line. Okay. Similarly, you can see here this distance is called as face width. That distance is called as face width. Okay. Then circular pitch, pitch circle. In other diagram, I think the thing will be more clear. So this circle, the circle up to which the other tooth gets engaged. What I'm saying, the point up to which other tooth gets engaged. Up to that point, the circle is called as base circle. इसके नीचे भी और एक circle होता है. Okay, that is called as root circle. Okay. Then pitch circle. Now what is pitch circle? When your two gears engage with in theory of machines, you might have studied this. What is pitch? First, what is pitch point? Pitch point क्या होता है? Pitch point. Okay, just let us take these two are the gears. Generally, gears engage with each other at the pitch circle. Where they engage? At the pitch circle. मतलब जो भी एक point होता है, there is one point. Do you know pitch point? What is that? Point where
two circle.
it is the point of contact between the two teeth. And ऐसे सभी points of contact को अगर आप connect करेंगे, तो जो भी circle बनेगा, that circle is called as pitch circle. All the points of contact, if connected, then the circle which you get, that circle is called as pitch circle. Okay, and the point where that contact takes place is called as
Pitch point.
pitch point. So in this case, this is the
Pitch point.
pitch point. Okay, this is pitch point, and accordingly, this is pitch circle. This is also pitch circle. This is pitch circle of pinion. This is pitch circle of gear.
Gear.
Pitch circle is denoted by center line. You can see in the diagram. This is pitch circle, which is denoted by center line. Okay. Now other terms are clearance. Clearance definition we will see later on. Fillet radius. There is always radius at the bottom. Teeth are never like this. Okay. If you say this as one tooth of a gear, it is never like this. Okay. There is always some radius, something like this. That radius is called as fillet radius. Fillet, you know, fillet chamfer. उसका जो radius है, that is fillet radius. Okay. These two are important terms, addendum and dedendum. We will write these in definition later on. Hold depth, again working depth. Okay, just don't bother about this right now. Now here it is shown. Here is the point of contact. Okay, so all such points of contact joint will give you pitch circle. Okay, उसके अंदर वाला जो सर्कल है, that is base circle, और सबसे बाहर वाला जो सर्कल है, that circle is called as addendum circle. Addendum circle, pitch circle, dedendum circle, and सबसे नीचे base circle. Okay, so how many circles are there? 4. Addendum मतलब सबसे बाहर वाला. So if I take this as a one tooth of a particular gear, then circle passing through all outer teeth. ये कौन सा सर्कल है? That is called as addendum circle. Okay, circle passing through all pitch points. Pitch circle. Circle passing through all the dedendum, that means the point where you get dedendum, that is dedendum circle, and the circle passing through all such root points is called as base circle or root circle. Okay. Now one more important term, that is called as pressure angle. Pressure angle, that is very important term in gear design. What is pressure angle? You can see here. Now whenever I draw tangent to both the circles, what I am saying is this one circle, कौन सा circle है? Pitch circle. This is second circle of the other gear. दोनों को common tangent कैसी होगी? Common tangent to both the circles. दोनों के लिए common tangent यही होगी ना? This is common tangent to both. Okay. But if you see the line of action of force, whenever two gears engage with each other, there is always certain force getting induced. वो force की line of action जो होती है तो that line of action always acts along this line. What I am saying is line of action. Line of action मतलब जिस line के along force act होता है gears के ऊपर. जैसे कि ये gear जब इसके साथ engage होगा तो this will exert certain force on this gear. And when this gear engages with this, it will exert certain force on the opposite gear. So ये gear का जो line of action होता है that is along certain line. So this angle made by this line with common tangent is called as pressure angle alpha. And in involute type of gears that angle is generally 20 degree. There are three systems. One is 14.5 degree, 20 degree and 22.5 degree. कितने systems हैं? 3. 14.5, 20, 22.5. Okay, but mostly used system is 20 degree full depth involute. That system is called as 20 degree full depth involute. Okay, so that pressure angle you can see. This is line of action and this is common tangent. दोनों के बीच का angle is called as कौन सा angle? Pressure angle. Okay. बाकी circular pitch and all we will see later on. So pitch surface is imaginary rolling circle, pitch circle, addendum circle. Now we will start from here. First of all, first definition, pressure angle. Pressure angle, it is the angle made by radial distance between addendum circle and pitch circle. You just see radial distance मतलब along the radius, distance along the radius between addendum circle and pitch circle. That means this distance, this radial distance is called as addendum. Next time dedendum. Addendum in bracket you write down. Addendum is denoted by HA. Now we are going into terminology. Addendum is denoted by HA. Next time dedendum. Radial distance between pitch circle and dedendum circle. Denoted by HF. Dedendum is denoted by HF. Next, clearance. Difference between dedendum of one gear and addendum of other gear. Is called as clearance, denoted by C, small c. So in the form of equation I can write this clearance as HF minus HA. That intentional clearance or distance is always provided. Okay, it is this distance in the diagram. You can see here. This small distance is called as clearance, which is dedendum minus addendum. This is dedendum. यहाँ से लेकर यहाँ तक क्या है? Dedendum. And यहाँ से लेकर ऊपर तक क्या है? Addendum. Okay, so dedendum minus this distance addendum. It means that dedendum is always slightly more than addendum. इसका other meaning क्या है? Dedendum is always slightly more than addendum. In actual practice, HF is always greater than HA, and that difference is called as clearance. Face, face you understood in the diagram. इसके definition लिखने की जरूरत नहीं है. Face, flank, tooth space. Now coming to the next definition, circular pitch, important one. Circular pitch. It is the sum of sum of width of a tooth, and space measured on the pitch circle. Okay, you see in the diagram. Circular pitch क्या है? Sum of tooth thickness. This is tooth thickness and this is tooth space. You understood the meaning? This is tooth thickness and this is tooth space. I will show you the diagram. Okay, so if I go along the pitch circle, ये मैं अभी क्या ड्रॉ कर रहा हूँ मैं? Pitch circle. Okay, so pitch circle के along, this is called as tooth thickness. Tooth का कितना thickness वो कहाँ पे measure करते हैं? Along the pitch circle. And tooth के बीच में क्या space है? It is also measured along the pitch circle. So this is tooth thickness and this is I call it as tooth space. This plus this is called as circular pitch. Okay, circular pitch is denoted by PC. Next line. So therefore PC, circular pitch, is equal to. Now how will you get that circular pitch? Because it is circle. So what is circumference of circle? Pi d. And what is this? Number of teeth. But don't use that notation. I am giving you another notation. Pi d dash upon z. Pi d dash मतलब क्या है? Circumference. Z is number of teeth, right? Where d dash is pitch circle diameter. Pitch circle diameter. अब इसको हम शॉर्ट में we call it as PCD. PCD मतलब pitch circle diameter, and Z is number of teeth. So Z is the notation used for number of teeth. Okay. Therefore, circular pitch is equal to as. Now we'll follow these. These are the notations used by V.B. Bhandari book, and we'll follow all those notations. Okay. So pi pitch, circular pitch is equal to pi d dash upon Z. Next line, diametral pitch. Diametral pitch. What is it? Ratio of number of teeth to the pitch circle diameter. Ratio of number of teeth to the pitch circle diameter. It's called as diametral pitch. And most important parameter of gear design is module. Okay. Denoted by M, small m. What is it? It is the ratio of, write down, ratio of pitch circle diameter to the number of teeth. You can see diametral pitch is number of teeth upon pitch circle diameter. Module is pitch circle diameter upon number of teeth. Therefore, module and diametral pitch are inverse of each other. Yes or no? Module is 1 upon diametral pitch, or diametral pitch is 1 upon module. So we get one important relation. What is that? M is equal to d dash upon z. Therefore, what is d dash? D dash will be m into z. आपने ये इक्वेशन ऑलरेडी यूज किया है डिजाइन में. क्या इसका मतलब? Diameter, pitch circle diameter of a gear is given by module into number of teeth. So if you know module and if you know number of teeth, you can calculate pitch circle diameter of the gear. Okay. Next, center distance or center to center distance. Center to center distance is given by. I am just drawing this figure again. This is say pitch circle diameter of one gear, pitch circle of other gear. These are the center lines. So what is center distance? Distance between these two axes is called as center distance. So how will you get that? It will be radius of this plus radius of this, right? Radius will be diameter by 2 plus diameter by 2. That's why it is written as diameter by 2 plus diameter by 2. Now what is dp? Pitch circle diameter of pinion, pitch circle diameter of gear. So write down. It is given by 1 by 2 dp dash plus dg dash. Here dash notation is for PCD, pitch circle diameter. But just now we have seen diameter is given by mz. So instead of dp dash, what I can write? mzp. Yes or no? And dg dash I can write as mzg, where zp is number of teeth on pinion and zg number of teeth on gear. So henceforth we will use notation p for pinion and g for gear. Okay. So ultimately you can take module out. So final equation for center distance is m zp plus zg by 2. This is the simplest equation for calculating center distance. Now these are the standard proportions. Proportions of standard module P. Okay. So all the values of the parameters like addendum, dedendum, then clearance, all they are always expressed in terms of what is this? In terms of module m. It's not meter. What is this? M. That means addendum is always equal to module. Dedendum is always equal to 1.25 times module. We just write this down. Standard proportions. Standard proportions. Now these proportions are for which system? Just please pay attention here. There are three systems as shown in the diagram. 14.5 degree, 20 degree full depth, 20 degree stub system. Now these are some systems of gears depending upon their manufacturing method. So we generally use this one. So you write down standard proportions for 20 degree full depth involute system. Full depth system involute. What is involute? Involute is a type of curve. टूथ का जो surface होता है, surface, this surface, it is always in the form of involute. Okay? So ये curve का नाम है involute T. So write down addendum HA is equal to module. HF is equal to 1.25 times module. So what will be clearance? Clearance का definition क्या है? Clearance is HF minus HA. HF 1.25 times module minus HA 1 module. Difference कितना हुआ? 0.25 times module is clearance. Working depth, hole depth. Working depth मतलब module plus module. That is HA plus HA. और उसके साथ क्लियरेंस ऐड हो गया तो that is hole depth 2.25 times module. Tooth thickness. Tooth का thickness कितना होता है? 20 डिग्री सिस्टम में 1.5708 टाइम्स मॉड्यूल. याला मीटर म्हणायचं नाही बरं का, मॉड्यूल म्हणायचं नाही तर मीटर म्हणाले एवढा इसका मीटर. जितना टूथ थिकनेस है उतनी क्या है टूथ स्पेस. ओके, दे कैन नॉट बी डिफरेंट.